Okay. Today we're going to talk about how fractions can have different names but be the same thing. They cover the same part. Excellent. I have this shape here. What does this look like? What do you notice about this? Elena. Oh, so much louder, so much louder.
It's a hamburger.
Looks like a hamburger. Great. Alina.
It looks like hamburger.
All right, something different. We know it looks like a hamburger. What else? Becky. Yes, keep going.
It's very, it's got different toppings.
Okay, excellent. How did you know it had different toppings?
There's different colors.
Great, Haley, add on.
All the different colors are circles is what I was going to say.
Oh, talk more about that. Stretch that idea.
There's the bun, the top part and the bottom part are the same color, and those represent a bun, I would think.
Yep.
And then, if they're circles, and then the brown part is like a brown patty, and that's a circle. And then the yellow part is cheese, and that's a circle. And I think those are all tomatoes, and those are circles. So they're all circles.
Excellent. We have something on the top. What do you think this pink guy could be? What do you think? Tomato? I mean, Haley's saying the red's tomato.
Oh,
What do
I
you think,
didn't
Melissa?
see that.
Onion, sure. We'll call it onion. Okay, excellent. So what I hear you saying, everything in here is the same circle shape. You're noticing that there's different colors. We are going to be working with these. When we work with these pieces, they might look like Frisbees. Are we going to use them as Frisbees? No. We're going to use our materials appropriately because that's what I'll be looking at when I'm doing all of our checks. So we'll use this. I'll show you how we'll use this later. Excellent. So we're going to start off. Erin was very hungry. Erin ate part of the pizza. She said 5/6 of the pizza is left. What did she say? What did Erin say? Mercedes?
5/6 of the pizza is left.
Left. Excellent. I'm going to circle that. That sounds important. Becky said 10/12 of the pizza is left. Elena, what did she say?
She has 10, 12 of the pizza left.
All right. So she's saying 10/12. She's saying 5/6. I love writing on the problems because then I can really be thinking. So sometimes I just interact with it as we go. So who is correct? What is the question we are being asked, Kayla? Excellent. Is Erin or Becky correct? So that's what we need to figure out. So we're going to look at this picture. What do you notice about the picture? Devin, what's one thing you notice?
That there's 6 pieces,
How did you know that?
because you have 5 pieces that have pizza on it and then 1 empty space, and I counted.
Okay, excellent. So did you count 1, 2, 3, 4, 5, 6?
Yep.
What you did? Did you really?
Well, in my head,
Okay, but you went 1, 2, 3, 4, 5, 6.
yes.
Okay, did anyone do it a different way? Michelle?
Did 5, there's 5 there, and then plus 1 because that was
Excellent. Anyone do it another way? Cassie?
I did 2 plus 3, 5, and then I counted that there was 6 lots total, but that was okay.
Excellent. So you did the 2 and 3, and that gave you 5, and then 1 more 6. Excellent. All different ways of counting. That is fantastic. Whenever you're dividing something, what do you notice about the size of those pieces? Becky?
Each are equal to the other.
Okay, each are equal to the other. What's an, oh good, yes. I like that nonverbal. That's fantastic. Say it again.
Each piece is equal to the other pieces.
What's another way to say that? Each piece is equal. Excellent. Oh, wow, that is an equivalent.
It's a big word.
Excellent. I'm going to write that down here. Tell me about that. What does that mean?
Okay, do you want me to answer?
Yes.
Oh, okay. That they're all like equal sizes. Or equal parts.
Okay, great. I'm going to put that here. Equal. Parts, sizes, great. Excellent. That is great vocab. So whenever we're dealing with a fraction, I want to start with this. What is that word? And what does it tell you? Melissa?
The denominator is the total amount of pieces that make the whole.
Excellent. I apologize. I dive into things so quickly and then it gets going. I wanted to just take a pause. So can we take a pause for a second? Let's see. I think that I wanted to,
Are you teacher or?
I'm teacher, but I just stepped off the actual teacher stage. So Amy, could you do me a favor as we're working? So right now we're in the do now, we're in the no, we're in the I do. See, I missed. I wanted to capture the pacing per section. So we're in the I do. So could you just write down the start time and then when we launch to a group? Yes, perfect. And Erin, could you record from here on out all the questions that I asked? So you guys can participate, but you're also.
As much as you can.
Okay, okay, yeah, do the best that you can. That would be great. And then, just straight down, exactly, perfect. And then Devin, this is a tough one. From the back, do you think you could record who raises their hand and who gets called on? So this is a system. So raise your hand like this so that Devin can see, and you just acknowledge if you see a hand raised. Circle it if they're called on, and a C if I cold call.
Wait.
Yep.
See if you cold call.
Yeah.
Circle if called
So
on.
it's I circle. So like say right now, Brianna's hand, Michelle's hand is raised.
Oh, and I circle.
Exactly, if I call on her, you just circle.
And then an I is
Exactly.
voluntary, gotcha.
You're not gonna get everything, this is just a sample, yes.
As a teacher, would you be doing all three of these? Like, what would?
No, exactly, you won't be doing any of
Would
these.
you pretty much, no.
These are the type of data that I'm going to be doing for you. So you're not doing any of it, and you're not asking your students to do any of it.
No, I know,
Yep.
but like, as the teacher, would you like have these on your desk and like?
No, you won't be able to do any of
Yeah,
this.
you
I was
would not
gonna
be
say.
Exactly, no. You won't be doing any of this. I just want you to realize these are the types of things one might analyze in a lesson. And so we're just gonna collect some sampling data. When I come in and sit in the back of a lesson, I might keep track of these sort of things. Like, I'm gonna write down verbatim the questions I hear. Then afterwards, we're gonna talk about it and say, what do you notice about these types of questions, things like that. Exactly. So this is not something that you have to do, but it's something that hopefully can influence your type of thinking. Okay, perfect. Yes, do that.
Oh, so do I gotta put an I?
Or like right now you would, but wait till I'm back on the like full teacher mode.
But do I put an I if they raise their hand and were called on, or if they raise their hand in general?
Excellent. So Devin's asking, does he put an I if they raise their hand or only if they're called on? Think about the type of data you might want. What do you think?
Doesn't he just do a tally mark and then if they're called on, do a circle around it?
Exactly.
So I'm gonna keep putting tallies every time.
Exactly.
Every single
All right,
time.
easy here,
Exactly.
Everyone just raise your hand.
Exactly. All the time.
Everyone raises.
Everyone
Just keep your hands raised till
It's set up like how everyone is sitting, although like this. I apologize. I should have this upside down. That's terrible. I didn't think of that.
That's okay.
So this is me, and then you know this is Aaron. So you can
Oh,
see
yeah,
like
well,
that.
I know.
Okay. And what's the goal? Why would I want that sort of data? Why will I want this?
I'm sorry, I just called out. Can I sit behind?
Move where you look. Exactly. Yes, great.
Seems participating in your lesson, or not.
Excellent. It's sometimes called attempts to participate. What you might see is Alina on here is raising her hand 10 times, never gets called on. Then all of a sudden she's trying to have a behavior problem. Well, I never included her in the lesson. So that's my fault. So you need that sort of data to see who's trying to participate and who are you including. What you often see with that is like this side of the room, I face, they get called on a lot. I don't face here, they don't get called on as much. Questions about that? All right, so sorry, I meant to do that right from the beginning of the hook, so I really missed it, and that happens. So we just keep going.
We forgive you.
Exactly, we gotta keep going. All right, so we're back to this. So denominator. So Elena, did you just tell us about the denominator? Melissa did, excellent. Okay, tell us again, Melissa.
The denominator tells you how many pieces the whole is broken down into.
Excellent, I love the way you stretch that. Haley, explain that again.
The denominator is the total number of pieces you have. Pretty much.
Excellent, let's get a little bit more exact on that. The total number of pieces. How can we be even more exact? And we're gonna use a little bit of Elena's language. Cassie.
The denominator is the total number of parts that are broken down to that are equivalent to whole piece together.
Oh, interesting.
I don't know if I said that right now.
You're saying to take the whole and break it down as the total number of pieces. Melissa, add on.
The denominator is the total number of equivalent pieces that make the whole.
Excellent. Say that another way. Alina.
The denominator is equal parts that make up a whole.
Great. Excellent. So the key is if I drew a shape like this, is my denominator 3? Kayla.
No, because they're not very equal parts.
Excellent. I love the way you stretch that. Fantastic. Great. Let's get rid of that so we don't get confused. So I always like to start with that. I want to know I have this whole thing and it's broken into equal parts. How many? So even though it's on the bottom, that's where I start. The numerator tells us what? What does the numerator tell us? Amy?
How many parts are left out of the whole?
How many parts are left out of the whole? Let's think. Does it always tell us that? Cassie?
The numerator is the part of the fraction that are being shown that are part of the whole. I know, it's really hard to explain.
If I had said, what fraction of the pizza did Aaron eat?
There you go.
What fraction of the pizza did Aaron eat? What is the numerator there, Haley?
1. Wait.
No, I said, yeah, I said, what is the numerator? And you said 1. Exactly, the numerator would be 1. And I'm pausing because you're going to stretch that idea and you're going to explain.
I was gonna be it'd be 1 because there's 1 piece missing out of the total of the 6. So Aaron ate 1/6 of the pizza, but there's 5/6 left. So the numerator for this one would be 5. There's 5 equal pieces of pizza left
Excellent.
out of 6 total.
Excellent. So when Amy said we're talking about the numerator is what's left for this specific problem, absolutely. The numerator answers, it's the parts that you're focusing on. It's whatever's being asked. It's the answer to that question is the focus of the numerator. It's telling you that. So let's think about this. I know blank is equivalent to blank because the same blank is identified even though it's divided into different parts. We have to work to fill in these blanks. That's what we are not sure what we're going to do there. But before we start, on your page, I want you to do steps 1, 2, and 3. A quick stop and jot. You're going to tell me what does the denominator tell you? What is the numerator? Show that fraction in the space below. Oh, and I like the way you saw solid lines, so you're writing in full sentences, using that restating of the question. Excellent. Excellent. I see eyes up at the poster. If you want that as a reference, that's great. And then step 3, for problem 3 there, you're showing 5/6 in that shape. Good. Good, good. I like what you're thinking. So that's where we're headed. Excellent. That's great. All right. Great. If you look at your partner's paper, raise your hand if where her empty rectangle is in a different place. Raise your hand if, and you can do it, that's right, you go, keep going. Raise your hand if it's in a different place. So Kayla, what did you and Aaron talk about in terms of that?
It doesn't matter that we shaded it different blocks because we still shaded it in 5 equal blocks.
Excellent. So some had the empty block here and some had it there. What if I had this? sort of a combination of what Kayla and Erin did. Would that be okay? Alina?
No, because it doesn't show 5, 6. It shows 4, 6.
How will I fix it?
To shade either the top box or the bottom box.
Oh, I love the way you said either. Great. Why does that fix it?
Because now it shows 5, 6 instead of 4, 6.
Haley, do you agree with what Alina said, and why?
I agree with what Alina said because now there's 2 boxes shaded on the top and 3 boxes shaded on the bottom, so that's a total of 5. And there's 5 boxes shaded, but there's 6 boxes total. So if there's one left out, 5, 6 is represented.
Excellent. What a nice stretching. Who could say the same thing using the words numerator, denominator, and equal? Numerator, denominator, and equal. Explain why this represents 5, 6 using the words numerator, denominator, and equal. Oh, I like people are thinking. Great. Devin,
Oh.
call on yourself. Yes.
Hold on. This is really
That's okay. It's all right. You're fine. Yes. It's a rough estimate. Yes. Keep going.
The numerator is the part that's shaded in, and the denominator is all of the pieces.
Excellent. Stretch that, but I want to hear equal and connect it to 5, 6. Becky.
The shape represents 6 equal parts and 5 hidden shapes. Of the equivalent shapes are shaded in. So the 5 would be the numerator, and there's 6 total pieces, equivalent pieces, so 6 would be the denominator.
Excellent. And I love where you put in that word equivalent there right at the end. So that would be a paragraph response. If I said explain why 5, 6 is represented in this picture, that's what you're doing. You're stretching your ideas. Could you get away with saying there's 5 things shaded and there's 6 boxes? Possibly. But we are great mathematicians, so we are going to stretch our ideas and we're going to use all that great math vocabulary that you have. Raise your hand if you have a question. Excellent. So Cassie was getting ahead of us. Our question that we're trying to figure out is, we have to prove who is correct. So we have 5, 6 represented, but then Becky is saying, that's 10 twelfths. So we need to think about that. So in the space on page 3, show me 10 twelfths. And you're going to say to yourself, there's only 6 boxes. But you know what the denominator means. So you're going to do something on a picture to show me 10 twelfths. How many equal boxes are you going to make, Brianna?
What?
How many equal boxes are you going to make in this picture to show me 10 twelfths?
Well,
How did you know that?
that's the denominator, so that's how many equivalent parts you should have as a whole.
Love it. Excellent. Go. All right, I saw some great counting and some excellent line drawing. So this is Erin's pizza, and then Becky has this pizza and says, oh no, that's 10 twelfths. So we need to take the shape and we need to do something to it. Amy, I saw you very carefully. Can you describe to me, what should I do to this pizza?
I need to cut each piece in half.
Whoa, pause that, because that sounded excellent. You need to cut each piece in half. So this goes in half. This goes in half. This in half, this in half, this in half, this in half. Why?
Because you need to make 12 pieces out of the 6. So to get that, you now have to have 2 pieces within each 6, like 1/6.
Excellent. This is very confusing where to draw these lines. Who can help me to explain that again? Haley.
To piggyback off of what Amy said, you have to split every box in half because half of 12 would be 6, and that's what we started with. So in order to go from 6 to 12, you have to multiply it by 2, so break the boxes into 2.
Excellent. Oh, yes, I heard a lot of multiplying and dividing there. Keep that locked away. We're going to keep working on that. So let's do the same thing to Erin's pizza here. Excellent. All right. So now, what should I shade on Becky's? Mercedes.
10
Okay. Now, what if I shade like this?
You can do whatever you want.
Okay. You could, absolutely. But if we're trying to see if you put them together, if they'll lay on top of each other, what would make it easier? What would be a better way to check? Michelle?
If you left the top to right back to the right.
Exactly. Imagine you're laying it right on top. Oh, sorry. Look at that. See, I did. Okay. Excellent. So who was correct and how do you know? See, three thinkers. Who was correct and how do you know? Great. Elena.
It's both of them.
And loud for Devin over there.
Realize both equal to each other, because they're both like have the same number of boxes shaded.
Okay, excellent. Do they have, so this had 5 boxes shaded in. This has 10 boxes shaded in. Tell me more.
You cut like Aaron's pizza into 12 pieces. Technically there's 10, and then Becky has 10.
Okay.
Wow.
Oh, I see. So when I do those dotted lines, you see that cut it. Excellent. Mercedes, add on.
5/6 is a simplified version of 10/12.
You used a whole new language there. Now you're going to need to prove that to me.
Okay, so if you have 10/12 and divide the top and the bottom by 2, you will get 5/6.
Why can I do that? Why can I just all of a sudden divide the top and bottom by 2? Stretch that.
They essentially have a common denominator if you were keeping. So if you were divided by 2, it would make it equal. I don't know.
Okay, good. Let's figure that out. Because we were taught that, but we have to figure out why. Why is it okay to do that? Becky?
They have a common divisor to can make 2.
They have a common divisor.
Yeah, so
But what does that have to do with up here?
because they can both be divided by 2.
Um,
Really.
yes, that's true. That is true, that works here, but what if, could I put a 4 there?
So you have to do what you do to the bottom to the top.
Why? So that's, you do to the bottom what you do to the top. Why? Haley?
I would go the other way, like say 5, 6. I would do multiplication because I know that 6 is a multiple of 12 if you multiply it by 2, and I know that 5 is a multiple of 10 if you multiply it by 2. So it's the same way backwards.
Excellent. I love that. And we know that multiplication and division are related because we've studied our fact families, so we are great at that. But I still need to know why that's okay. Why do I have to do the same thing to the top and the bottom? Amy?
It kind of goes, sorry, so I guess the way you have to do it is you always do everything to the top that you would do to the bottom of the fraction, because it will not be an equal fraction if you were to use 2 different numbers to multiply that. So that's how you can always know that like 5, 6 is
Excellent. Did you want to add on, Brianna?
That's what I was gonna say.
Great. I'm just going to add on a fine point to this. So this would be an example, sort of, I'm doing some heavy lifting here. 2 over 2 is the same as what number? 2 over 2, Kayla, is the same as what number? 1. Any number multiplied by 1 is what? Any number multiplied by 1 is what? Melissa? Excellent. It's self. So that's what you're doing here. You're multiplying 5, 6 essentially by 1. You're dividing 10/12 by 1. You have to choose what that's going to be, and that's where you get those multiples and factors that you're talking about. But that's the rule for why you do what you do to the top to the bottom, is you're basically doing it by 1. Excellent. We're going to prove this even more. So I know that you all are experts at this, and I'm sure your parents at home teach you this way, but now you're going to show me with different representations. So I'm going to put you with a partner, and you're going to show me with your fraction hamburger exactly how you can show me 5, 6, and 10/12. So you're going to build it. As you get your pack, you're going to see there's lots of colors in here. what are the only colors that you need to pull out of your bag? What are the only colors that you need to pull out of your bag? Erin?
I don't know what colors they are, but it's just pulling out the 6 and the 12.
Excellent. Okay, great. So you looked up there, and why did you choose the 6th and the 12th?
Because that is the colors that we're working with.
Great. Okay, so you're going to have a bun, and you'll pull out the 6th and the 12th. So that's going to be your purple, your red and your pink. So you're going to work with your partner and pull those out, and I want you to prove to me that it's equivalent, that both Erin and Becky were correct. All right. So you will have that on your paper right when you're done. If you all could just be a group of 3. And Erin, you have, they're right next to you. Yep. And maybe, Devin, if you want to come back and do, yeah, so if you two, and then Erin, you just pass one down to Melissa.
Are you done, am I done with this, or did you want me to hold
For
on?
now, yes, if you want to, we'll see, how'd it go? Any interesting conclusions? Right. Excellent. Exactly. And you too, yes. Yeah. That's great, we'll stop with that, and we'll talk about that. That's great, thank you, good.
Could it have to do with content, maybe? That would be content,
Content, what do you mean?
like the topic.
This?
Yeah, I associate with content.
Tell me what you're saying.
Yes.
Oh, no, I do, oh, so you're noticing that, I was noticing that, and so that's my,
Yeah.
got it. I think that's one factor of saying like you okay, John.
Well, I always, oh,
She's right now on the question.
that's,
Yeah,
oh, that's like it.
yeah,
What the other-
I'm you, and Amy. But Amy's just in direct time, so it's very, yeah, yes, yeah.
Okay, that's good.
Yes.
Yeah.
Oh, shoot.
Exactly.
It's like, I would,
Exactly, think about it.
when I do these things, I think about, so I actually focus on that.
Yes.
That's a good way. I don't know what it was.
No, it's absolutely, that we also to make sure everybody has even.
I don't know why you sent it to me, like saying I should tell you not to get this.
Yeah. We'll talk about that. Excellent, great data, thank you.
Yep.
All right, excellent. Oh, I love when you pulled that out, great. All right. Keep going. So short of that. Great. Oh, excellent. I see people really lining it up nicely. Melissa and Michelle, could you show me though with the pieces missing? What do you need? No, you're perfect. Leave it right like that. But show me what was Oh, good. I like the way you're flipping. Good. Excellent. All right. Excellent. Oh, I see a partner not getting along. Yes, you must use the materials appropriately. That's good, but it's very common. All right, excellent. I love the way everyone was using the materials appropriately. I had checks down for each person. Almost, no. And you would never want to do that. Never. So I had checks down to note how well everyone handled the material. What I can really see is you're showing me exactly what's represented there. So what shape is this pizza? What shape is this pizza, Devin?
Rectangle.
Excellent. What shape were you working with, Cassie?
Circle.
Circles. So you can apply the same thinking to different shapes, but could I compare this, if I said she ate 5/6 here, and Becky said 10/12 here, did they eat different amounts? Could I compare these two?
Abstract.
What do you mean hard? Tell me about it.
Because they're not the equal sizes, so kids won't be able to compare them.
Excellent. You can't. You must have the same whole. So if I said to you, you have a 1/6 and you have 7/8, who has more? Who would you think has more? 1/6, 7/8.
7/8.
Melissa, why do you think 7/8?
I would think it would be 7/8 because even though the denominator is higher, well, not even though, the denominator is higher, what the numerator is a higher percentage of
Oh, that was great explaining. Explain that another way. 1/6, 7/8, yes.
There were, it's observed that there were more parts, or the parts were closer to the whole in 7/8, as opposed to only one part of the 6 whole.
Excellent. But this is why we can't compare without knowing the size of the whole. If I said, Becky, did I say you had 7/8? Becky has 7/8 of $1 million. Haley has 1/6 of $1. Who has more?
Honestly, I have no idea.
1/6 of $1, 7/8 of $1 million.
7/8 million dollars.
Exactly. So, but that's why you want to think about it. Or I apologize. To illustrate, I should have flipped those. Haley has 1/6 of $1 million.
Oh.
Haley's 1/6 of $1 million. And Becky has 7/8 of $1. So now, even though her fraction is smaller, her whole is bigger. So you must know the size of the whole. That's a big piece. You must know the size of the whole, and then you can work with those ideas. Excellent. All right, so let's look at our sentence frame on page 3. I know blank is equivalent to blank. What are we trying to compare here? So we're on page 3. Oh, sorry, is it page 3? Yes. Excellent. Brianna.
I know 5/6 is equivalent to 10/12.
Excellent. 5/6 is equivalent to 10/12. Because the same blank is identified, even though it is divided into blank parts. So this is tough. What would you say is there, Erin? Whole. The same whole. I'm going to give you this one because it's tough, and I think even sometimes the books get it wrong. The same section. The same section. So this is the section here. This is the section here. Same section is identified, even though it's divided into different parts. What's happening? What do you think, Haley? What's going on?
I would not have gotten section.
I know. A lot of your books will say it is the same part. Because it is the same part of the pizza, but that gets confusing because these are parts. So it's like there's a lot of parts. So I call it section, yes.
Not to like jump out of the student role.
Do whatever you
but
need to, yeah.
Would you have, like, should we have introduced the word section in the beginning of the lesson, you think?
Yeah, that's a great idea. Exactly. So maybe now I could apply it. So what do I mean by section? What is covered here? What section of the piece is covered? Yes, Haley.
5 out of the 6.
Ex-
So, also, you mean like section is just another word for part? then?
Exactly.
Okay.
Exactly. Without saying the word parts, because then it's like, wait, I have 5 parts, I have 6 parts, and it's a part of a pizza. So it is. You can think about it as part and section are sort of synonymous. I just like to say what section. So you're laying these over each other, so you can see the 10/12. That section of the pizza is covered, and but 5/6 is the same part of the pizza, the same section of the pizza. Excellent. All right. So